Hello everyone, this is Meraki fan. Today I would like to walk you through on some of the latest features on MX firmware 18.2. We have already talked about some, such as traffic exclusion. So today we are going to talk about BGP. If you are familiar with Meraki MX, we are supporting a few routing protocols such as static route, OSPF, BGP, and so on, which includes supporting for both eBGP and iBGP. However, prior to firmware 18.2, we support eBGP only on MX in 1R mode, a card concentrator or pass-through mode. There are lots of benefits for BGPs, especially on dynamic routing exchanges between AutoVPN with customers' routing domain, and avoid on asymmetric routing problems and so on. From version 18.2 onwards, we have added on supporting BGP on MX in routed mode. There are many benefits and use cases, such as if your MX deployed at spoke site, which require MX to peer BGP neighbor with upstream ISP router and exchange routes via eBGP and use iBGP to re-advertise to the hub site. Another good use cases, which I'm going to demo to you later, an MX deployed at data center, which require peer eBGP neighbor with the downstream DC core routing equipment, like in the topology you can see. And it will learn the route from DC via eBGP and re-advertise to its AutoVPN peers spoke sites, for example, via iBGP. In another way, the routes at the spoke site, you can have many spoke sites, many routes, which you will advertise the routes via iBGP to the hub sites and re-advertise to the DC site via the eBGP. Without any further ado, let me dive into the actual demo. Let's review topology last time before we come to the demo. So you can see that in the data center site, we have the MX establish a BGP peering with the router here located in the DC. And the most importantly, we are establishing the eBGP peer from the LAN side of the MX, right? So on the spoke side, it is as a normal MX set up by the internet. Okay, so let's come into the MX hub site. Okay, so come to the security and SD-WAN, go to the routing. So you can see that BGP routing has already been set up, right? So I have already pre-configured those things to show you guys. And there are a few important fields you have to set up, like your own BGP VPN AS numbers. So do take note that this number is going to be an iBGP AS number across your whole organization, right? And all these host timer you can leave at default, or if you have any special parameters, you can just input them for yourself. And the neighboring IP is very important. You must take in the correct neighboring IP, which is in this case is the router IP in the data centers. Their AS number as well is 65511, and the most important in the source interface IP you must choose. In this case, the correct one is our LAN, one of the interface we used to establish the eBGP peering between the MX and the router side. Okay, everything is at default. So now let's come to the router side. So in the router side, we can see that we have set up the BGP as well, and you can see that our AS number is 65511, which is matching with the neighboring AS number and neighboring IP, right? So I'm also peering. This is my router ID, my local router ID, BGP router ID, and I'm actually peering with my neighbor IP, which is in this case MX 172.1.16.1.3, right? So and the AS number also matching, right? So and if you do say that show IP BGP topology all, then you can see that the routes and the neighbor has been established as well. BGP summary. So you can see that neighbor has been successfully established, and with the message received with that the AS number, right? So that's the peering part. How about the routing? What we have learned from the spoke side, and the other way, what we have advertised the routes from the router through our AutoVPN, and in the area advertised to the spoke side. Okay, so first thing first, and we still come back to the router configurations. Okay, so we can see that we have advertised the 172.16.1.0 subnets to the BGP routing domain, right? So that means that at my MX hub site or MX spoke site, I should receive the routes. Okay, so let's verify that. Okay, so in this case, if I come to my hub sites, okay, come to the routing table, take a while to load, and you can see that this 172.160.16.1.0/24 has been learned by external BGP, eBGP, right? So the next hop destination is the point-to-point interface IP, right? Okay, so and this is actually has been learned, all right, and if let's say we come to the spoke side, this is the spoke side, and if come to the routing table, we can see that 172.16.1.0 has been learned from the eBGP. Can you see that? As well explained that the 172.16.1 has been learned from the MX side to from the ISR routing, right? ISR eBGP routing, eBGP, and re-advertise to the eBGP, right? So this is how we actually learn the route from the hub to the spoke. Okay, so same thing goes that for my spoke side. Let's take a look on my local routing, my local subnet, which is 10.1.33.0.24. This is my local VLAN, and I've created for this test. And same thing, if you can see, show IP route BGP, you can see this 10.2.33.0 has been learned by the by the eBGP, right? Because this route has been advertised by the eBGP to the hub, and the hub re-advertised the same routes to the the router side, the core router side inside the DC by the eBGP, right? So it may sound a little bit mouthful, but if you learned on how this thing works, it's actually pretty straightforward and simple, right? So that's all about my demo. Hope you liked the video, and see you next time.